folks, we come back with our next video. We finished in the problem 8 in the previous video. Now we'll take up 9, problem 9 and 10, maybe 10 also. So let's try. So that's how it is. Let's read the ninth question and see what it says. The ninth question says that a balloon which always remains spherical has a variable radius. It's a sphere, has a variable radius. Find the rate at which the volume is increasing if with the radius when the later is 10 centimeters. So please mark the words. First of all, the balloon is spherical. That we have understood. Then they say that you have to find out the rate at which the volume is varying with the radius. So that means you have to find out the derivative of the volume with respect to the radius. So it is dv by dr that we need to find. So that's how it is. We have to decide. Sometimes it is dv by dt, sometimes it's dv by dr. And they give us that the radius is 10 centimeters. So with the help of this, we'll have to find this out. So goes without saying that r is the radius of the sphere and v is its volume. So what we get to know here is that here the radius is 10 centimeters. And the volume, we all know, the volume by formula is O by 3 pi r cube. So because it's a sphere, we know that the formula for the sphere is this. Derivative is with respect to r. So let's find out the derivative. 4 by 3 pi r cube has got the derivative. Yeah, r cube has got the derivative 3r squared. Because it is with respect to r, we need not write anything else. And that's how it is. So now let's get across doing this and see how it goes. We have the 3 getting cancelled, and they've told us that the radius is 10 centimeters. So 10 into 10. Your answer comes out to 400 pi centimeter cube per centimeter. So that I think you can write 400 centimeters squared. That's how it is. So that's how we find this out, and it comes out to 400 pi. That's about the ninth question. Pretty simple actually. Now we'll go to the 10th one. The 10th question says that a ladder is 5 meters long, is leaning against the wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is the height of the wall decreasing when the foot of the ladder is 4? Yeah, quite many things. So it's like you have the wall over here. This is the wall. Obviously, this is the ground. And this ladder is kind of leaning like this. This ladder is leaning like this. Ladder's length is 5 meters. This could be called as a ground, and this could be the wall. They ask us to find a certain thing when it is at a distance of 4 centimeters. 4 centimeter or meter. Yeah, 4 meter. They say, yeah, let it be. It doesn't matter much as far as the units have to be the same, whatever that it is. So that's about it. They tell us that this is moving, they're pulling this, you're pulling this ladder. When you pull the ladder, this distance is moving at a certain rate. They tell us that rate. They tell that it is moving at the rate of 2 centimeters per second. And they tell us if the height is reducing, then at what rate is the height reducing, that they are asking us to find. Suppose say if we call this distance as x and this distance as y, then this is actually dx by dt. And they ask us to find dy by dt. That's the question. So this is how the question is all about. You are given that the length of the ladder is 5. They tell us that whenever the ladder is at a distance of 4 meters from the wall, then in that case, what will be the rate at which the height is reducing? That's a question. So pretty okay. And we know that we are into a right triangle over here where we have chosen to call this as x and this is y. So because we are in a right triangle, we know we can use Pythagoras theorem. So we can write here x squared plus y squared equal to 5 squared. Why we get this? We get this by Pythagoras theorem. So what will happen? In order to get the dy by dt, this is the only way in which we can, actually we have to have some formula or something from where we take the derivative and get the answer. So for us, in this existing condition, this is the only formula that can be used in order to find the derivative. So let's right away go on to find the derivative, taking derivatives on both sides with respect to t. Derivative of x squared with respect to x is 2x, but then with respect to t, so we'll account for it. Again, derivative of y with respect to y is 2y, because we are looking for with respect to t, so we have to account for it. Phi squared being a constant, derivative is 0. So what we get over here is, we get maybe 2x dx by dt. We can take this term on the other side, minus 2y dy by dt. The two can cancel each other. We know that we have to find out dy by dt. So dy by dt is for us minus x dx by dt by y. So that's simple. Now you can find the dy by dt. But the problem is, you know x, you don't know y. So we have to find out y. Y we can find out easily by Pythagoras theorem because you are already in a right triangle. So we can write also x squared plus y squared is 5 squared. That way 4 squared plus y squared equal to 5 squared. Like that 5 squared can become, sorry, y squared can become 5 squared minus 4 squared. So that is like, either you take it as a plus b into a minus b. You know that a squared minus b squared is always a plus b into a minus b. Either you can take it like that, or you can take 25 minus 16. So you'll get the answer as, if you're taking 25 minus 16, you'll get the answer as 9. If y squared is 9, then y value becomes 3. So we could use both these, together from 1 and 2. What do we get? We get dy by dt to be equal to minus x for us is 4, y for us is 3, and dx by dt for us is 2. So it's minus 8 by 3. They're told that is reducing. So minus 8 by 3 therefore can be minus 2.66. So either that you write it like this or minus 2.66 centimeter per second. That's the answer. So that's how the height of the ladder is decreasing. That negative indicates that there is a decrease. That's all for this video. With more problems, you can come in the next video. Thank you.